right, we'll go ahead and get started. Hey everyone, my name is Kendall and I work on Near Protocol. So Near Protocol is a proof-of-stake sharded blockchain. And yeah, we're going to talk a little bit today about how to write smart contracts for it. So just give you guys a little quick overview of like what we're going to do. Start off just going to introduce a little bit more about Near and how it works. And we're going to set up a little dev environment. We made it super simple for you guys. It's just going to be one click and spin up a web IDE. Then we're going to write our first smart contract in Assembly script, which is basically a strict subset of TypeScript that compiles to WebAssembly. We're going to deploy this contract and an example front end so you guys can kind of see how it works. And then we're going to write a second smart contract in Rust that is basically going to interact with this Assembly script contract. And as a bonus, which I think we will have a little bit of time for since we're starting early, we're going to deploy a Solidity smart contract to Near using Truffle. Show you guys how you could maybe combine Near with your hacks this weekend. All right, so yeah, just a little quick overview of what Near is. So Near is a public proof-of-stake sharded blockchain, and we have a WebAssembly-based runtime that currently has full support for Rust and AssemblyScript. We'll explain what that means in a minute, but really anything that compiles to WebAssembly could, in fact, work on Near. So we'll just cover a couple of key concepts that makes Near a bit different from, say, like Ethereum, for instance, or other blockchains. So one of the first concepts, we have kind of a somewhat unique account system. Conceptually, at least, this account system is basically like a smart contract wallet or like the Ethereum name service. So the way it works, each account has a name, like a human readable name, so that's like 2 to 64 characters. It's going to have a balance in Near. It can have contract code or not, and if it does have contract code, it's going to have key value storage for this contract. And then probably the concept that you guys are most familiar with, so we have each account is going to have access keys, and these are actually public key, private key pairs. And so what's cool is that each account can have basically no access keys, which means it's kind of like locked. So if it has smart contract code, it's basically a locked smart contract, and that code will never change. Or it can have dozens of access keys, and you can interchange these keys whenever you see fit. So we actually have like a add and remove key action that you can take on your account. So here's just like a little bit of like a visualization on this. You can see full access keys, like this account has 3 full access keys, and we can remove those as needed. And then if you see that little, it says new corgis, that's actually the name of a smart contract. And so this is using what's called a limited access key. And so a limited access key can actually be scoped to just one smart contract. So basically it can be used to call any function in a contract, or it can even be scoped to just a single function in a single smart contract. And then you can set like an allowance for that function or for that key. So in this case, it has like a very small little Near balance to call the Near corgis contract. So yeah, the next really important concept, as I mentioned, we have a WebAssembly runtime. So basically you just compile your smart contracts to WebAssembly, and then you deploy the WASM file. And so what we mean by full support is that for Rust and AssemblyScript, we basically have some pre-written smart contracts that give you some like powerful functions. Like if you're familiar with in Solidity, you have the message, and from message you can get the sender, you can get the value that was attached. That's like that's basically supported, and we'll actually go through an example of this in just a second. So the third concept to cover before we actually get coding, the way that contracts work on shards is actually like it's kind of unique to Near. So despite the fact that we are a sharded blockchain, there is actually still just one blockchain, and every single cross account or contract interaction is going to be considered async. And the reason for this is that we don't actually have same shard guarantees in Near. And the reason for that is that we use this concept called resharding. And so what this means is that contracts and accounts can actually shift shards. So the reason we reserve this right to basically have contracts shift shards is that if a contract is, for instance, growing very large, has a lot of activity or even state, it can even grow to maintain its own shard. So there's some interesting patterns that can arise from this. And then probably the most important thing when it comes to reasoning about your smart contracts is to know that while calls actually can be returned in a later block, they're always going to be atomic. So you never have to worry about if say the first part of your contract call succeeds and the second part fails, you don't have to worry about there being an inconsistency there. It is basically going to roll back the transaction. So just a little visualization here. On the left, you can see like a pretty standard like beacon chain design, very similar to what like the ETH2 current spec is going for. And then on the right, you can see the way that we're doing things. So Nightshade is kind of the name of our sharding system. And so basically what happens is that each shard is going to produce a chunk, and then all the chunks of so a chunk from each shard is then going to be contained into a block. So we actually do still just have one blockchain. You don't have to track a different blockchain for a different shard. So yeah, just a little summary here. So those are going to be atomicity between shards. A couple links here if you're interested in learning more. If you want to see like a very detailed breakdown of how cross-shard transactions work in Near, you can check out this link, near.ai/xshard. And if you're interested in learning more about how we handle data availability, you can check out near.ai/nightshade. All right, so now we'll go ahead and actually get to writing some smart contracts. So if you're interested in following along yourself, you can just go to this website right here. And that's basically going to spin up, take you to a GitHub repository. And in that GitHub repository, you're going to see a blue button that says Open in Gitpod. And that's the one-click web IDE that we're going to be using today. So what we're going to be building is just like a very simple messaging app. So this is basically, you can see right here. So there's going to be two types of messages. There's going to be like a standard post, and then there's going to be a premium post. And this premium post is going to demonstrate how you can basically charge for certain function calls in Near. It's really just to show you guys kind of how our smart contracts work. So here's the environment right here. This is basically what you'll see if you just click on that Open in Gitpod button. And yeah, it's kind of cool. It's just like we have a Docker container that's basically going to be deployed that'll already have all the dependencies installed, so it makes things like nice and quick. So probably the first thing to cover here is just like the contract structure. Fortunately, everything, by the way, that we're going to be doing today will be in this README, so if you want to follow along later, feel free to do that. It doesn't render so well here, it's kind of dark, but the contract structure, or basically the structure of our project, so we have contracts, and under contracts, you're going to see two folders. There'll be assembly and Rust. So that's basically going to be, we'll write the assembly script contracts in this folder and the Rust ones in here. So if we look at the assembly script folder, where we have three files here, the two of which are the most important, there's going to be this like main.typescript. This is where we're actually going to write most of the code. And then we have this model.typescript, and this is like, if you're familiar with TypeScript, which is where we're just going to define some of the types. And then for the front end, this is basically just some example code. We won't really be going into too much depth today, but this main.javascript file is kind of the most relevant. This one's just going to show you kind of like how you can actually interact with smart contracts from the front end. So yeah, let's start with just this model.ts file. So here we're actually just going to define like the one type that we're going to be using today. So we'll call this posted message. And we're going to have just like a few different attributes here. So we'll have a sender, which would be the string. This is actually going to be like the account that is sent the message. We're going to have just like the body of the message, which we'll call text. And then because we're going to designate between premium messages and non-premium messages, we'll just define this Boolean here. And then if we go over to this, you can see we're just going to like import this type from the model file. And here's where things get kind of interesting. If you see here, this is like where we're using what's called near runtime TypeScript. And so that is actually like that helper library that we were talking about before. So what we have here is context. And context you can kind of treat as a combination of like message and block, if you're familiar with Solidity. This is where you can get like the sender, and this is where you can get like the block height, for instance. And then we'll be importing one more object here, which is called persistent vector. And this is basically like a helper data structure that we have for you guys. It's essentially like wrapping our storage parameters. And so if anything that you define in this persistent vector will basically automatically be treated as something that should be stored on the blockchain. So this concept is also very similar to Solidity patterns, where you have like memory data structures and then like storage data structures. This is here we're just like defining or like importing like a uint 128. So I mean, Bignum is not actually a library that we wrote, so this kind of shows you can actually use some external libraries in your TypeScript contracts. It's sort of dependent on the library itself. You know, there's going to be some things that won't be supported, but it's definitely worth trying out. All right. So as you can see here, we just like defining like the one data structure that we're actually interested in this smart contract. So that's going to be messages. So we're just going to instantiate a new persistent vector, and that persistent vector is going to be made up of different posted messages. The only thing that's actually a little bit near specific here is we have this here, like M, and that's basically just to make sure that the key value store is unique. So we'll just make this one M. All right, so now actually getting to writing some functions. So the first one we're going to do is going to be add message. And so this is actually going to be what we call like a change method. So this is actually going to change the state of the blockchain. So yeah, I mean, this is like pretty standard TypeScript here. So we're just like it's going to take a single input, which is text. It's not going to return anything. And then we're just going to like define this message here. So the type is going to be a posted message. Here's where we actually use context. So as you can see, we do context.sender. So that's going to pull the account of whoever it was that was actually like sending this message. So basically, whoever called this function will be the context.sender. Then text, and then this like premium. This is just going to check if this should be a premium message. And so the way we're going to do that, we're using context again, and we're going to pull this like attached deposit. And this is very analogous to the like message.value from Solidity. So we're just going to check if it's higher than, well, this is basically like 0.1 near. We actually do have some good helper libraries that we didn't use in here that are like make it so you don't have to know like basically what's is called atto near. It's like similar to Gwei, so you don't actually have to know this if you use some of our helper libraries. And then here we're actually going to push it to messages. So as you can see, we defined messages here. We're going to push this message, and so this will actually store it to the chain. So that's the first function, and then basically the read function. So this is what we call like a view method, and this is again like familiar with Solidity. This is basically just using like a view method in Solidity. So we're actually going to return an array here, and it's going to be an array of these posted messages. So I mean, you probably are thinking like, why return array versus persistent vector? It's basically because persistent vector is actually going to be storing something to the chain, whereas like array is just an in-memory data structure. And so since we only care about it to return the result, we don't actually need to store it anywhere. So we're just returning the array. I mean, here, yeah, we're kind of using like just a defined constant up here, which is message limit, just so that we only return 10 messages. So not particularly interesting. Like here, we actually create this array with the messages that we returned, and just going to iterate over it. This is basically just like only returning the most recent 10, and we return the result here. All right, yeah, I mean, that's actually just the first smart contract. So now the fun part, we get to deploy this. So we actually tried to make this as simple as possible. If you look at our documentation, you can see like a step-by-step breakdown of how this works. But we have like a nice little helper script here, which is just going to be dev. So dev is actually just going to deploy this for you. And so it's going to do a few things. It's going to create a new account for your smart contract. It just is going to be like a dev one. So it's just going to like pick one for you. It's then going to deploy the contract to this account, and then it's going to like call the first contract function and also run our front end. So we just type npm run dev here. Give it 1 second. We can kind of see it's building the contracts. So this is actually building. It's going to create a WebAssembly file in this out folder here called main. So it's going to be the same as what we called like the TypeScript file. And here you can see it's starting the deployment, and we are deployed, done deploying. So it deployed to dev 158 whatever. And now we have our front end running. So yeah, using Gitpod, we can just open the browser and we can actually see this application. So here we are. This is now live. We can log in with the Near wallet, get redirected to Near. So we can see Near Guestbook is requesting to access our account. Check more info. We can see what the actual contract is. We can even open this up in our Block Explorer and see it was basically created and a contract was deployed. And, back here. We'll just authorize this. So this is actually just like basically creating a limited access key on our account. And we'll just allow that, and we're back. So now we can actually select between the two different message types. So we'll just check this one out. First one to post the message. And there we go. And what's cool, and as I mentioned, the limited access key pattern, basically what we did is we added a key that was scoped to just this add message function on the contract that we deployed, and we added that to our account. So my account is called ETHDenver demo, and so basically what that means, like we actually have the private key of that limited access key stored on our front end here, and you can kind of dig into the front end and see how that's working. And so what this means is like users don't actually have to go and sign another transaction when they want to actually interact with this smart contract. But if we do want them to do that, we can use this second function here, premium post, and see how that's going to work. So this will actually like redirect us back to the smart contract. this is basically getting pulled by default from the URL. That's why it's like kind of so ugly here. And as you can see, this is actually requesting that we're going to transfer the 0.1 near, and it's going to be calling this function here. So this is like the premium message that we're paying for it. So what we usually do is if you want to actually require the transfer of near in a smart contract function, we require you to get an explicit signature from the user. And that's just to protect the users from accidentally sending you a ton of near without really knowing what they're doing. So we'll go ahead and allow that. See transferring here, and transfer successfully will be redirected back, and bam, there's our premium message. Cool, so to recap here, what have we done? We've basically written an assembly script smart contract with 2 different calls. We've deployed the contract to the test network, and we've then interacted with it in 2 different ways. So now we are going to write a Rust smart contract that's going to talk to this contract, and is actually going to use 2 different types of cross-contract calls. So we'll go back here. We'll go to our Rust folder here. So as you can see, we have some like Rust-specific stuff here. We've got like the cargo files. This is like the main one. We've got this little build script here, which is basically going to like use like the WebAssembly project, and it's going to deploy or basically build this file and then output it here, and it's going to output it in this folder here, this like result folder. So I actually went ahead and built it just because it does take quite a few seconds to build a Rust smart contract, but we have like a nice little helper function here that's just npm run build :rust, and that'll go ahead and build your Rust contract. So we'll actually go over what this Rust contract is, so you can kind of see how things are going to work if you're interested in using Rust. All right, so Rust works extremely well. We're extremely excited about it. That being said, like we have a lot of helper functions to make things easier, and there is a little bit of like kind of setup required, like a couple of boilerplate inputs for you to get started. So the first thing you have to do is import this like what's called Borscht. It's basically like a serialization library. And then kind of the main thing, and this is like very similar to like our near runtime TypeScript library that we had you import in the TypeScript file. This basically includes a lot of helper functions. So environment is where you're going to be able to use like context to actually get like who sent the transaction, how much they sent, and like block information. For our cross-contract call, we've got this like external contract little object here. And so this, we'll actually go through how this is going to work, but this is basically used to wrap like the interface for the contract that you want to interact with. Then near bindgen itself, kind of like a self-referential import, and then a promise. And we'll talk about how the promises work in just a second. You also have to import this like global allocator, and then most importantly, you have to define like the struct, and this is basically like the name of your smart contract. We're just going to call it cross contract to keep it simple. Make sure you tag it with near bindgen. And this little kind of messy pattern here, we're going to try to like hide this, but for now you have to basically define this once, and then you don't have to worry about serialization anymore. And yeah, here's probably one of the more interesting little functions. So this is going to be our external contract. So we can call it guestbook. And as you can see here, this is actually the same methods that we defined before, and it's going to have the same inputs with a little bit of like Rust magic. So this one is mutable, so that's how you can tell that it's going to be a sort of like create function, and it's actually going to be like mutating state on the blockchain, and it's going to take in again the same input as the other function. Yeah, sorry about that. Thank you for pointing that out, by the way. It's getting kind of into. Let me yeah. Is that better? All right. Cool. Thanks, guys. Yeah. All right. So yeah, just to kind of show this again. So these are basically exactly matching the functions that we defined in this TypeScript contract, since we're going to be calling it here. So it's going to be add message, which is this mutable method. That's why we have that like mute string there. And it's actually going to be taking in the same kind of data structure. So it's just going to be a string here, which is text. And then same thing for get messages. And what's kind of cool is, I mean, the data structures are actually a little bit different between Rust and TypeScript, but they're still going to be compatible in this cross contract, which is kind of cool. So this is the get message, which is actually going to return this vector of strings. And that's similar to the array that we returned here, this array of posted messages. And again, I mean, interesting that it doesn't actually require any sort of like knowledge of what this is going to be. And then we'll actually implement the calls here. So just again, you have to tag it with near. You have to basically tag like each implementation with near bindgen. We'll call it cross contract because it's implementing this struct here. And we're just going to do two functions to kind of just demonstrate how things work. So the first one is this add message. And so in add message, we're actually just going to do a very simple call. So we're just going to be calling from guest book. We're going to be calling add message. It's going to take in text. Text is actually the only argument, if you remember up here. After that, we do have to add a few more additional arguments. The most important one being this like account ID. This is actually going to be the account ID of the contract that we're calling, which, if you remember, is probably that like ugly dev contract name. Then this is going to be the amount of near that's sent with it, and this is going to be the gas. So that's add message. And then if we want to actually use a promise, and this is how you would do like more like complex cross-contract calls, we'll call this add and return messages. So same kind of thing. It's going to take in just like this text string and also the account ID, and it's actually going to return a promise. And so if you can see here, so the first one is this exactly the same. We're just like calling add message, but then we can use, because it is a promise, we're going to use like then to basically define what comes next. And here we're actually going to then call the get messages function. Like same kind of pattern, doesn't actually take anything in, so we don't need to use text there. And this is going to return itself, so we're actually going to be able to then print out basically the messages that were returned. So yeah, that's the Rust contract. Now let's go through how we can actually deploy it and interact with it. So let's go back to here. So that's actually running. All right, so we already built it on here, but if you're following along, you can run this npm run build-rust, and that'll go ahead and build the contract. And then there's a few things that we have to do. I'm going to just walk you through how you actually do like from scratch contract deploy. And so if you're trying to follow along here, we have these instructions here. So we already built the contract. Now we're going to do near login. So this is actually just going to log into like the near account that I'm going to deploy this from. So if I just click this here. All right, 1 second. Opens this here. So we're just going to authorize near shell to basically have access to our account so we can deploy contracts. Confirm that. And we're back. All right. So now we've stored that there. Next up, we're going to create an account. So this is going to be the account that we're going to deploy our smart contract to. So we'll just keep it simple. Denver 123. And I have to basically let it know which account I want to actually use to fund this new account. All right, we've now created Denver 123. Now we need to deploy the contract. So this is a little bit ugly. Let's actually open up another file here. Sure, it can be a text file. This is why we have the helper scripts to make it a little bit simpler. Oh, wait, one more, this one. All right. All right, so this is the account ID that we're going to be deploying it to. So we just created that Denver 123. We already have the WebAssembly file that we're going to be pointing it to. As mentioned before, it's just going to be this one right here. It's called guestbook.webassembly file. Master account is the one that I've been using, so this ETHDenver demo. And now we'll deploy this bad boy. Boom, starting the deployment, and we're done. All right, so now we've deployed it, and now, as you see here, we can actually call it. So we're just going to call it for the command line just to give you guys an idea of how it works. So we'll just call this second function here, this add and return messages. So we want to call Denver 123. We'll put in the account ID that we deployed that first contract to. That's this one. And let's give it this message. All right, good to go. And if we pull up, I think this was it. Bam, there we go. So we see that it actually sent the message to our assembly script smart contract where all this is stored. And it also returned to us all of the messages that we've seen before. So now we have deployed a Rust smart contract that interacts with our WebAssembly contract and used the cross-contract call and a promise to return the result of that call. So the sky's the limit what you can do there. The promise structure is actually like pretty interesting, you can actually just touch on that real quick because I think it's worth showing you guys. You can use it basically as like a factory for contracts within a contract. So let me just pull up this. You can see here, this is actually where, so what we do, just within this call, using the promise, we're going to create a new account ID. We're going to then transfer it a bit of near, add a full access key, and then deploy the contract. And if we wanted to go a step further, we could even then call methods on the smart contract after that. So it really is like a pretty powerful little function. We're working on the documentation to make it a bit better, but if you have any questions and you're interested in learning more about this, please come talk to us. All right, cool. So yeah, that is pretty much what we had for this specific demo. So I'll actually just go back to the slides here and we'll talk about some of just one more thing that I think is probably worth mentioning. So we just finished the EVM support for Near. And so the way this basically works, we deployed the basically Rust implementation of the EVM compiler that was written by Parity as a smart contract to the Near blockchain. So it's cool, using Truffle and using this custom Web3 provider we have, you can actually deploy your contract to basically your EVM bytecode to this contract and then interact with it as though you would in a normal application. And what's also cool, so then if you use this Web3 provider in Web3.js, instead of using MetaMask, for instance, you can use the Near wallet that we just demonstrated to interact with your Solidity or Viper or anything that compiles to EVM bytecode smart contract. So I'll go ahead and just show you how you can how simple the deploy is basically, and then point you to the repo of where you can use this yourself if you're interested. So I've actually been demoing this a little bit, but it really is as simple as just doing truffle migrate, setting the network as Near, and wait for this to deploy. Show you saving the migrations. All right, we are deployed. Now, if I can remember where I had the Explorer. So this is our block Explorer. Finished at explorer.nearprotocol.com. Here we go. So we can see Denver EVM is actually the contract. And then we just called it a few seconds ago. We called deploy code, and call contract is basically calling the init or the constructor of the contract, because we don't by default call instructors unless you specify that. So yeah. Pretty simple. We can actually just look a little bit. Here's actually the code. This is basically just setting up your, so this is all you have to do basically to set up your Truffle file. We have a little example, which I'll give you the link for in just a second if you want to see this yourself. And you just have to basically use the Near provider, set the network as Near, and you can go ahead and deploy it. So nice and simple. And then to interact with it, just change the provider to the Near provider on your front end in your JavaScript code, and you're pretty much good to go. So yeah, if you'd actually like to do this yourself, near.ai/near-evm, or come talk to us. We're super excited about this and happy to talk you through it. And just one last little point here, and then we actually have a couple minutes left, so I could take a question or two if somebody has one. But we do have some bounties this weekend. So we have 3 bounties for you guys. So if you use the cross-contract calls that we just demonstrated in Rust, for the best implementation of that, we're going to give away $1,500. We are interested in technical, the technical implementation here. So if you try to use any advanced patterns that are basically in the examples that we have, that's kind of what we're looking for there. If you really like to talk more about this, just find anybody wearing the Near t-shirt. Another one, if you deploy, and this one's actually super simple, and we're hoping we get a lot of submissions here because we just think it's quite a fun one to do. You can deploy any Solidity or Viper contract to Near and use the Near wallet with that EVM support we have. We're also going to give away $1,500 there. And there we're really interested in just kind of the most user-friendly solution, because we're pretty excited about the way that our wallet works and would love to see what you guys can do with it. And then the last one, and this one we'll kind of see. So we have a Near to Ethereum bridge that we're super excited about. And it is ready, but we don't have very good examples up just yet. We're actually working on them as we speak. So hopefully it'll be done by this evening when we further announce the bounties. But if you use this in any way, and a very simple way to do this is you're actually going to be able to transfer assets between Ethereum and Near. That's probably the simplest way to use it. If you just use those newly transferred assets in your Near smart contracts or in your Solidity smart contracts, then that technically makes you eligible. So we're definitely interested in creativity here, and love to see what you guys come up with. Yeah, and those are our bounties. Thanks, guys. We'll be around all weekend, so please come talk to us if you'd like to learn more about Near or are interested in engaging with our bounties. Thanks.